Got a whole variety of topics here in this nugget on DNS or advanced DNS that, to be honest, they're kind of difficult to tie these topics together. I think I was talking in one of those earlier nuggets about the amalgamation of all these miscellaneous things that happens sometimes with these exams, and this topic is no different. In this nugget, we'll talk about implementing the advanced part of a DNS solution. And I think what they mean by advanced DNS solution is all the stuff that you probably wouldn't necessarily do in every case, but you should probably still know. So I actually recorded this, so a first round of this, and decided to throw the entire thing away because it started to get really muddled in how I was explaining all these different topics. So I'm going to try something different here, and we're going to go through each of these topics one at a time. Let's start with just the assumption that you already have a DNS solution in place. I kind of assume that you do because you have Active Directory already up and functioning. Well, when you have that DNS solution in place, it offers DNS services, but there may be some additional protections that you may want to lay over the top in order to protect the zone files, to protect the cache from poisoning, to lock it down to different administrators, to view the logs, just a variety of stuff that it might be interesting for you to take a look at so that you can protect yourself from some bad person trying to point your users in the wrong direction. In this nugget, we're going to talk about a variety of these things, like DNSSEC, and then socket pools and cache locking, the logging, the delegated administration, which is essentially the security tab. A neat thing about recursion, and another neat thing here about net mask ordering also. I'll kind of explain some neat stuff there. If you haven't played yet with a global names zone also, global names zones are a way, kind of, sort of, that you can use if you're looking to get rid of wins out of your environment. Hopefully you're not still one of those people or one of those environments that has wins laying into place. If you do, global name zones are one way to kind of try to get yourself out of that wins, eliminating that wins situation. And then there's one quick command, or one quick PowerShell command that I want to show you that is associated with analyzing zone level statistics. So, as I said, this is kind of round 2 for this because round 1 just ended up a muddied mess. So I want to go through these one step at a time here so that I can give you a good understanding of what you need to know. Let's start here with configuring DNSSEC, and then there's 2 little options, socket pools and cache locking. Now, DNSSEC is a solution that enables the server to more or less sign the zone so that when a client is requesting information from the zone, it has a better assurance, a greater assurance, that the information it's requesting is the same stuff that the server sent. Right? It's not been manipulated in transit, that nobody's gone in and made changes. And DNSSEC is a completely optional solution. It is becoming more required for where certain, as part of certain regulations. I think I saw somewhere that FISMA now requires DNSSEC for zones, even internal zones. There may be other regulations that require DNSSEC to be turned on. The good news is that unlike certificates, DNSSEC does not require, certificates and all that extra complexity. And so the implementation of DNSSEC can be relatively trivial. Now, let me show you how you turn DNSSEC on. If I come here to a zone and I see DNSSEC, I can literally click here to sign the zone. If I want to just use the default settings, I'm done. That's all that's necessary at the server side in order to get this zone signing process to be enabled. This isn't like certificates where I'm proving the authenticity of who I am. I'm just validating that the information I'm sending is the information I'm sending. So the process is quite a bit simpler here. Now, most of us are probably going to want to go through the entire process of customizing the zone signing parameters when it comes time to enabling DNSSEC. But I will tell you that the only reason you would probably need to do this is if you have a need to adjust the values from the defaults. A lot of times your security regulations or your security people will want a slightly different type of encryption or a slightly different type of hashing that is done than what comes out of the default. And if that's the case, there's a real nice wizard here that lets you adjust what those parameters will be. The first of which is the keymaster, which I love this because it reminds me of that movie The Ghostbusters with the gatekeeper and the keymaster. The keymaster, as it its name suggests, is the server that generates and manages the keys for a protected zone. So if you have a bunch of different servers out there, you got one server that's responsible for managing the keys. Any authoritative DNS server, let me get my pen here, any authoritative DNS server that hosts a primary or Active Directory integrated copy of the zone can be the key master. So if you've got a primary copy, if you've got a writable copy, then you can be the key master. You can choose which one you want or the one that you've run this, that you're currently running the console off of. Then once you identify which one's going to manage the keys, there are a couple of different keys that you can then define what the configurations of those keys will be. The first is the key signing key. So this is what's used to sign the other keys. And if you want, you can identify a variety of configurations in here for how you want the keys signed, which algorithm you want, what length, what bit length do you want. Do you want to replicate the private key to the authoritative DNS servers? If you have an Active Directory integrated zone, you want to do this so that those keys are available throughout all the Active Directory integrated copies of the zone. I will tell you, if you choose or if you start this on a primary zone and not an Active Directory integrated zone, the only way that you can go about actually making that zone AD integrated is to come back in here and to actually unsign the zone before you make that move. So any of the major structural shifts in a zone require it to be unsigned and then re-signed again. Okay? So something to be aware of before you go through this process. So when we come in here and we identify what we want, we can set this up as just the default, or I can adjust these. Most often these are adjusted based off of, again, security requirements. How often do I want the keys to roll over? Sometimes this gets reduced to a smaller number of days. I have another key here called the zone signing key. So this is the key that's used to sign the data in the zone. As before, I can identify what kinds of information or what kinds of configuration I want on that key. The algorithm, the length, the validity period, and those sorts of elements. So if I need to change these, I will. I can then identify which of the protocols I'll use to authenticate that something doesn't exist, NSEC being the older protocol and NSEC3 being the newer protocol. Do I want to then enable distribution of trust anchors for the zone? Without getting into too much detail here about what these trust anchors are for, recognize that for a non-authoritative server, to be able to respond to a request, it needs to be aware of a trust anchor. It needs to be able to have that trust anchor so that it can respond to that, to that zone request. Otherwise, only the authoritative server will be able to make that response. So enabling the distribution is handy, particularly on the inside when I may have multiple different DNS servers that are participating in responding to clients. Choose next again here, and here are my signing and polling parameters. Again, kind of basic stuff here that may be adjusted based off of security requirements, and then I'm done. So this looks like a lot of things you need to set up in order to get DNSSEC up and operational, but in reality, most of these things are defined for you, and you may only change these if you're being told that you have to. Now, what we've done at this point is we've created a hash of the contents that exist here in this zone. That does nothing unless the clients are instructed to request the hash to validate the zone as part of their regular register request for DNS resolution. Now, the way in which we accomplish that happens most often through group policy, through what's called a name resolution policy. I can come over here to group policy, and if I come here to I would pick a better policy, but I'll choose default domain because I'm not going to configure anything permanently. Here under policies and Windows settings is a location here called name resolution policy. And it's here where we instruct our clients to actually ask for the hash that we just created. So I can say for my company, or for my zone, company.pri, do I want to enable DNSSEC? And then do I want to require the clients to check that the name and address data has been validated by the server? This is the client side part of the server side we just did a second ago. You can add a little bit more restrictions in here. You can define what your CA is. If you need to use IPsec, you can do that as well, but that requires a whole host of additional infrastructure to be laid into place for IPsec to be done as part of this. But these two checkboxes and the suffix here are what's necessary just to get the basics of this DNS registration up and operational. Now, along with DNSSEC, there are actually a couple of different additional configurations that you can set, or at least you should be aware of, that can further protect your DNS zones from external attack. One is to adjust the socket pool. The other is to adjust the amount of cache that's being locked. And these are pretty well defined as defaults, but you can adjust these if you feel the need to. More often than not, you're probably not going to need to adjust these too much. The first is the DNS socket pool. And the DNS socket pool is really just a pool of possible different source ports that a DNS server would be using as part of its requesting of information from other servers. So if you can imagine, so here I got a DNS server that, maybe it's just one server talking to another. When the server is asking for information from the other server, it's asking typically over TCP 53, sometimes UDP 53. That's the source port that the DNS server is actually looking on. But the destination port that the server is listening on. But the source port that this server is actually sending the request from could be one of hundreds or thousands of different possible source ports, typically ephemeral ports above 1024. In order to protect this server from some bad person out here, here's my little bad person with this bad person mask, nefariously attempting to respond faster than the DNS server can respond, one of the ways that we can protect ourselves is by just simply increasing the number of source ports that that server is using for DNS resolution. That process is done using a nifty little command here called DNS-CMD, which is by no means a PowerShell command, but it's just, this is easier for me to get a command prompt. DNS-CMD is a kind of a Swiss Army knife of DNS commands. And in fact, if I do DNS-CMD /?, you'll see the variety of things that I can accomplish with it. More or less anything having to do with DNS is something you can do here at the command line with DNS-CMD. The specific command that we want to use in this case is DNS-CMD, and it is config and socket pool size to some other number. 4,000, 5,000, 6,500 if I wanted to. Increasing that socket pool size increases the number of potential source ports and potentially can just make it a little harder for the bad guys to sneak an incorrect answer in when people are asking for DNS resolution requests. The other thing we want to talk about is DNS cache locking. Now, when a DNS server makes a request for name resolution from one server to another, so this is my DNS server. When it makes a request for name resolution, it actually stores a copy of that request inside a little local database called the cache. And this is important because otherwise, having to go out and find out where Google is all the time, Google doesn't change its IP addresses that much. So the cache is useful because, well, I can just respond directly from the cache from my little user here that's requesting information. It can respond from the cache directly instead of having to go all the way out to the internet to get the information. But there is a type of attack that exists in the wild that involves actually polluting this cache with fake records. So bad records. Here's my little bad guy again. There's his little mask. With my little bad guy populating fake records in this cache so that when a person requests the information for Google, they actually end up getting the information for bad Google instead. That's something we want to protect ourselves from. And one of the ways that we can do that is by literally locking the cache for an extended period of time. By default, DNS will lock 100% of its cache to prevent it from being changed. That amount of time is set to the time to live value for the record that exists in the cache. But I can actually adjust it with a little PowerShell commandlet here called set DNS server cache, and then locking %, and then set it to some other percent like 75. So It's 100% by default, but I could actually set this to a smaller amount if I was looking for, I don't know, a less secure environment. Sometimes I wonder why they ask these questions in here. So, all right, let's see. That's the first of our bullets that we need to talk about in this nugget. The next thing we have to talk about is DNS logging and probably delegated administration. Let's do logging and administration next, two of those. So these two are kind of interesting. You're probably aware that your DNS server has a couple of different kinds of logs, the first of which being the event logs here. When you turn on event logging, this is the logging this is the information that gets logged directly into the Windows server's event log. But sometimes there's the need to get a deeper level of data. Maybe you want to find out how many different clients are still resolving to a DNS server you'd like to decommission, or what the performance is of that DNS server. Well, in that case, there is the ability to log at a debug level the individual packets, the individual requests that are coming in. For those type of deeper level requests, for understanding how many people are coming in, what your performance is, turn this on, set your file path and name, and then pick through the logs. The usual caveats here for debug logging apply because this can require a lot of resources just to constantly report on everything that a DNS server is doing. So it's generally a good idea to leave this thing turned on only whenever you have need for it. Now, the administrative delegation topic here is one that's also kind of odd for this objective domain. The only thing you really have to be aware of is that if you intend on doing administrative delegation for a specific zone, right, you want somebody else to have access to create child objects in the zone or write permissions on the zone that isn't necessarily an administrator on the server. You have to have that zone to be an Active Directory integrated zone for it to work. Okay, so make sure that your zones are Active Directory integrated if you plan on doing delegated administration. Which takes us to our next task here, which is configuring recursion. Now, recursion is kind of a nifty one here because recursion is something that you could easily forget if you weren't aware of how recursion actually can inadvertently expose a potential exploit for your external DNS servers. And let's assume here that I got my domain. All right, there's my domain, and in my domain I have my DNS server. This is my internal DNS server, and I also have an external DNS server. Here's one that's sitting in a DMZ somewhere. My internal server is responsible for company.pri, so the inside zone. But the external server is responsible for the URL and the domain that the rest of the internet sees, company.com. Important difference between these two. The job of this external DNS server is very much different than the job of this internal server. And for a couple of different reasons. Let's assume that here I am again, got my little desktop, and here's me, happy little me, and I'm attempting to go to google.com. When I attempt to go to Google, if nobody's gone to Google in a really long period of time, well, one of the jobs of this internal server is to get me the request that I'm looking for. If it doesn't have google.com in its cache, well, the next step in that process is for my internal server to then go out to the internet to request that information, right? This process involves a process called recursion. I first go to the server responsible for .com. I ask it who's responsible for Google. I go to the server responsible for google.com, and I ask it for what's responsible for www, and so on until this server gets the authoritative response for www.google.com. Now, while this recursion process is very important so that happy little me can get access to all of my websites, it can be actually a big problem for my external servers. These external servers are not there. Their job is not to do recursive name lookups for anybody who happens to come a-looking. No, their job is only responsible to be the name holder for that external namespace, like company.com. And so as a result, any external name servers should have recursion disabled so that you don't end up creating a situation where a person could just keep sending you name resolution requests and propagate a denial of service attack on that external DNS server. Really important thing if you've got external DNS servers that you're responsible for, and solvable through a single checkbox, which is not located here, a single checkbox found right here. Disable recursion. Absolutely want to disable this thing on your external DNS servers only. Whew. So I told you there was a whole lot of miscellaneous stuff in this nugget, and just getting through this is kind of interesting. Okay. So the next one here is net mask ordering. And net mask ordering is another one of these special use cases that it's enabled by default. But I want to explain why it exists. Let's assume, for example, that you have, let's call it a WSUS server. And in fact, you don't have one WSUS server, you have 3 WSUS servers. Here's one. Here's 2, and then here's the 3rd one. Now these 3 WSUS servers you have set up in a round robin with the round robin DNS records, so that this one is 192.168.1.0, this is 2.0, and this is 3.0. Now if you recall, when we were dealing with the domains before, our 1.0 namespace is our Denver site. Our 2.0 namespace is our Las Vegas site, and our 3.0 namespace is our Phoenix site. So inside of DNS, I have 3 different records that are round robining 1.0, 2.0, and 3.0. This is nice because I have high availability and also load balancing for these 3 different servers. But if I'm a user that happens to be in Las Vegas, do I really want round robin to 1 out of every 3 times send me here to Denver? Probably not, because downloading my patches from Denver is going to take a much longer amount of time than is it if they're downloading from Las Vegas. Well, net mask ordering is a way to kind of override the round robinness of round robin to ensure that when a user happens to be sitting in 192.168.2.0, that round robin will always give that user the correct server in their local subnet, wherever appropriate. It's, again, awesome for like WSUS servers, great for web servers. Anytime I have multiple machines with the same name that may be in different subnets. Now, netmask ordering is enabled by default, but I want to show you where it's at. Here, I think it's in the properties of the server also, right here, right there. If I have round robin turned on, enabling netmask ordering will ensure that, again, if I'm in that zone or in that subnet, I'm going to get the server that is closest to me geographically. Nifty little kind of trivia piece there, and one that's obviously going to be on the exam. So what do we have next? I think the next one is our global names zone. A lot of miscellaneous stuff in here. I gotta tell you, doing this miscellaneous stuff is it's like the hardest thing to teach, because I like to tell stories, and it's impossible to tell 1, 2, 3, 4, 5, 6, 7 different stories without completely confusing people. So let's tell the global names story here. You remember WINS, right? WINS was a mechanism to resolve short names. If my server's name was WSUS, WINS only cared about that. Some people still have WINS these days. Well, global names is a mechanism in DNS to support short names, so literally host names without fully qualified domain names. And it can be a mechanism that you can use if you have resources that are still reliant on WINS. Hopefully you don't, but if you do. But you don't want to have WINS servers still around. That's one of the uses for a global names zone. Now, a global names zone is not available by default. You actually have to create it in order for it to be around. And the way in which you create a global names zone is to create a zone on a DNS server that's also a domain controller called, and this is funny, global names. And let me do that. Global names. The global name zone is by no means any kind of a special zone type. It's just an AD integrated forward lookup zone called global names. Once you create that zone and you enable it for updates there, then you can populate the zone with any of the records that you want to have, the short records. So WSUS, for example. Populating that with all the records will then allow your DNS server to resolve just the short name of WSUS to WSUS and whatever its IP address happens to be down here at the bottom. Now, in order for your other DNS servers to support this, you actually have to explicitly enable it on every authoritative DNS server in your forest. So every DNS server everywhere. And the way in which you accomplish that is back to our little friend DNSCMD, and the command is DNSCMD server name DNDC1 config, and then enable global names support 1. That will specify, that will tell that server that it needs to enable the support for global names. Maybe not the best way to get rid of WINS, but at least some way in which you can hopefully try to get rid of it, because short name support is something that some applications still require these days. And the reason for this is because when you look through the resolution order, if WINS, especially with old clients, if WINS is not available, then it will resort to DNS. And if DNS can actually resolve a short name, well, then you might be able to actually use this as a solution. No guarantees, but this is one way that Microsoft is apologizing for and helping you attempt to eliminate WINS in your environment. Got one more topic here, and that is this last one here to analyze some zone level statistics. And this one is actually relatively easy because there's just one or I think 2 different commands that you should be aware of. And the first of these is a lovely little PowerShell command called get DNS server statistics and zone name equals to, let's say, company.pri. So there's some interesting stats on your zone. So outbound transfers, inbound transfers, total dynamic updates received, what your record types are for queries, responded and name server errors. That's for your SOA type records. There's your name server records, and all the different record types that exist up there. There's your A records there at the top. One other tool that is probably easy to forget about is an ancient tool that I think first appeared back in the Server 2003 support tools. That's a tool called DNS lint, like the lint in your pocket. DNS lint is no longer available natively in the operating system, but DNS lint is a nifty little tool that can do some advanced level sort of testing on zones. And this is particularly handy when I have external zones, like those I'm trying to query against, the intranet's registration. Well, you can download DNS lint from Microsoft.com. It still works in Server 2012 R2, which is awesome. And I want to show you that the DNS lint command offers a variety of different options. But the cool part is in using it to look up different zones and information about zones. So DNS lint, let's do an external zone, like concentratedtech.com. That's my company. This is actually going to go out to the internet and request a bunch of information about the name servers and their registration and bring back an HTML file that we can read with a bunch of information about the health of this zone. After a second or so, the process will complete. It actually does take a couple of seconds for this thing to go through all of its analysis. It will create a report called dnslint.htm in your current directory. Now, surprisingly, it's not actually in this current directory. I believe it's in I found it actually, it's in the Windows syswow64 subfolder instead. And if I take a look here at the DNS lint report, here is concentratedtech.com. A couple of DNS servers are authoritative for this zone, right here and right here. And all the information that it was able to pull out of those DNS servers. DNS lint, very handy for those external addresses. So validating whether or not the internet is reporting you as authoritative for your own zones. You can use it for internal zones as well if you wish. So if I want to do an internal zone query, I can do DNS lint ad/est and then localhost. In this case, because I'm running it on the DNS server itself, to do a query on Active Directory. So there is that, and it's created the DNSLint HTM also in that same directory. And I believe if I now double click it again, I can see for company.pri, here is information about the DNS records, the records that are authoritative for this zone internally. So lots of different topics here. Like I said, I had to record this thing twice because I just couldn't get the storyline through because of all this miscellaneous stuff. Well, what have we talked about this nugget? We have talked about turning your basic, uninteresting, uninspired DNS solution into one that was advanced. Talked about the security settings, DNSSEC, changing socket pools, changing cache locking. Talked about logging and delegated administration, where you should disable recursion only on those external servers, why netmask ordering can be useful when I start doing load balancing and round robin of different servers, where a global names zone can come in handy with WINS servers, and then also a couple of the commands that you should be aware of for analyzing those zone level statistics. So it is with this that we actually conclude our look at the Active Directory stuff and at the network services portion of this 70-412 exam. We're going to move on from this point into some of the more advanced level services. And next up will be a new service called IP Address Management, or IPAM. IPAM is a nifty tool for helping you eliminate those spreadsheets of IP addresses that you probably have sitting around in a drawer somewhere for all the static addresses you have. And it can do a couple other interesting things as well when you hook it up into the other network services in your environment. That's the topic for our next nugget, so until then, I hope this has been informative for you, and I'd like to thank you for viewing.